Example 4, this is a fun problem. It's asking us to find the area, or take the area inside the circle x squared plus y minus 1 squared equals 1, and rotate that around the x-axis. And this is another one where we're just going to set it up. All right, so first off, this is a circle, and its radius is 1, and its center, if you remember about circles, the center, x minus h and y minus k, give you h and k are your the coordinates of the center. So the center is going to be at 0, 1. And if you have trouble visualizing that, just type that into Desmos. It'll plot it for you. So we've got this circle, and we're going to rotate it around the x-axis. So 0, 1. We're going to take this, and we're going to rotate that around the axis. And that's going to give us, this will be the bottom side. So it's almost like a donut, except for it doesn't quite have a hole in the middle. It's because it touches right there. So let's figure out how to do this using shells. Now, first off, if this weren't in the shell section, how would I know that I want to use a shell for it? Well, if you tried to do it with washers would be problematic because you'd have to solve for the bottom part and the top part. You'd have to figure out this radius and this radius. And maybe that wouldn't be too tough, but let's do it with shells. Now, I'm going to do a trick, though, or I'm going to use a trick to make this a little easier. I could draw the shell across here. Like this. But instead, I think I'm going to only draw half of that. And what we're going to do is find the volume of the half of the donut on this side over here as opposed to this side. And then we'll double it. All right, so let's see, we've got to come up with the radius. That's the radius. And we've got to come up with the height. That's the height. I guess we also need the thickness. All right, what's the thickness of this thing? Well, the shells are rotated around a horizontal axis. So the thickness is like from here to here. So the thickness is going to be dy. So we need to label all these points, namely this point, and this point, in terms of y. Okay, this one down here is easy enough. It's 0, 0. This point here, its x-coordinate is 0, its y-coordinate is y. This is the only one we really have to work out. Its y-coordinate is y. So what's its x-coordinate? Well, we've got to solve this up here for x. So we got x squared plus y minus 1 squared equals 1. So if you solve this for x, you get 1 minus 1 y minus 1 squared. So x is the square root of that. All right, and so that is, I'm just going to draw an arrow for that goes here. So our height is going to be that minus 0. Our radius is going to be, that's the length here, and so that's y minus 0. So the radius is y, and so the volume for this thing is going to be, now I'm skipping some space here. The formula for shells is 2 pi radius, height, thickness. And then we're going from one end to the other. Now, maybe I should have done this to begin with. The area that we're rotating around is the area inside of this circle. So when we're trying to figure out the start and stop of the area, since we're doing this with respect to y, what we want is the smallest and highest value of y in that circle. So the smallest value of y there is going to be down here at this point where y is 0. And the highest value is going to be up here where y is 2. And this is almost the correct answer. The thing that we're leaving off here is this is only half of it. So I've got to multiply by another 2 to get the other half, because this gets us the volume of, like I said before, just this half of the thing. And to get the other half, we got to multiply by 2. So this is our volume. Or at least it's an integral for our volume.